Okay, so now let's talk about classifying reactions. And often we classify by the five main types of reactions. And so you will see those five here. So the first is a combustion reaction. It's a very specific reaction type. And it's a combustion reaction when oxygen combines with a substance and releases energy in the form of heat and light. In this class, we're always going to have CO2 and water as our products for a combustion reaction. So what you'll find is the first reactant is usually a combination of C's and H's, or C's, H's, and O's. And then your second reactant is oxygen, which is again a Hofbrinkel, so O2, and it's going to yield CO2 and water. And so sometimes you'll see different names like methane is CH4, propane, butane, octane. If you hear of something that ends in an ane, it is a hydrocarbon, and there's actually a different naming system with these prefixes. So in the organic chem world, these prefixes are used. So meth means 1, eth is 2, prop is 3, but is 4, and then pent is 5, and then it's like the math ones. So the differences are these beginning prefixes. So methane, ethane, propane, butane. What they're actually describing is how many carbons you have. So that's a little mini organic chem lesson for you. Okay, so, and we could then draw the Lewis dot structure. If I know it's propane, and then I figure out how many H's could bond, and that's how I know it's H8. So that's a little addition for you. The next reaction is synthesis or combination. I have linked a video for you here as well. Now, in this kind of reaction, that means you have two different reactants forming one thing. So that's how you figure it out. Two things making one. So here I have iron plus sulfur making iron 2 sulfide. And there is two special situations I want you to pay attention to it. And that is a metal bonded to oxygen. That's called a metallic oxide. So metal bonded to an oxygen. And if you see CO2 as a reactant, when you bond these together, you're going to bond it and make a carbonate. The other special situation is a binary chloride, so something bonded to chlorine. So it's probably lithium, sodium, potassium, something like that. And oxygen are going to make a chlorate bonded to that metal. So be very careful when you see either these reactants or these products. It will help you to determine what those reactions are. Now, a decomposition is the opposite of a combination synthesis reaction. So here we're going to have one product breaking into its elements or something similar to that. So the way I think of it is like decomposition, decomposing a body. You're just breaking things up into parts. And so here I have water breaking up into H2 and O2, Na and 3 breaking up into Na and N2. And so we have the same special situations you saw before, but now they're flipped. So that carbonate breaks up into metallic oxide and CO2, and your chlorate breaks up into the salt with a Cl and O2. Same idea. Okay, now a single replacement reaction is where things get a little bit more interesting. So this is when one element trades place with another element in a compound. Okay, so we're going to do switcheroo. So if, let's say, A is positive and B is positive, those two switch. If A is usually a nonmetal, then it's going to switch with C. Okay, so it's either going to switch the positive ions or switching the negative nonmetal anions. And what happens is not all of these reactions occur, so we have to be a little bit careful. So if you look here, I have if the slope of the line goes up, then there'll be no reaction. But if the slope of the line goes down, there will be a reaction. Well, what does that mean? Well, that means we're going to use something called the activity series. And so I said Mg plus LiNO3 was no reaction, but Mg plus AgNO3, there was a reaction. So what we're going to find is this is our singles column. So these are my singles. And then this second column, these are my bonded ones. Okay, the ones that have bonds. So if I have magnesium here and I see lithium bonded, if my arrow goes up, no reaction. But if my arrow goes down, there is a reaction. So that means magnesium plus, let's say, aluminum nitrate or zinc nitrate or iron 2 nitrate, any of these metals below magnesium, there will be a reaction. So if the arrow goes up, no reaction. So if I have magnesium and calcium nitrate, no reaction. So you just have to be careful. The activity series is another thing that you're allowed to use on an exam. And so I will have a printable copy available for you as well on Classroom. So single replacement, just be careful with those. Now double replacement reactions, these are our most common reactions. And basically our ions are going to be switching place. So usually our cations are just switching. I call them the swinger reaction. They just want to try somebody else for a while. And so most typically this is the reaction that we will deal with. And so you'll see like sodium and copper, they're going to switch places. Here potassium and hydrogen switch places, hydrogen and sodium switch places. And often you can get different products out of these. Often you'll get a precipitate or maybe a gas or something like that. Very typical reaction that we will deal with. And I think very easy to identify with two compounds and two compounds. So if you're trying to determine reaction types, this is a flow chart you can follow. So you can see, does the reaction of oxygen as one of its reactant listed on the left side? And then you check, well, if does it have CO2 and water? Then you know it's a combustion reaction. Does the reaction have two or more reactants combining to form one product? Then it's a synthesis. Does it just have one thing breaking up into parts? Then it's a decomp. Does it have a single and a double? So that idea makes this a little bit easier to determine reaction types. So here's some practice. And so we can identify what is the reaction type. So here I go, okay, this is two things. So this is going to be a double replacement. Okay, if I look at this next one, O2 is a reactant. Oh, it's a hydrocarbon. I got C's and H's. CO2 and water is another indicator that makes it a combustion reaction. So this next one, oh, I got a single guy, +2. So this is probably a single replacement. Next one, I got two ions. This could be double replacement. Again, two ions, double replacement. Oh, a single and a single, making one thing. That could be a combo or synthesis reaction. And here's a single guy breaking into two components. That makes it a decomp. So that's usually a section I would do on the exam where you just identify the reaction type. And usually people do pretty well in that. So I do have some practice problems. This reaction type worksheet is hard. If you can do this, you are set for this unit. But because we're in this environment, I'm not expecting you to do this. It's not mandatory, but it will help you do much, much better on the exam. This is also a really great review for the exam eventually, and just to make sure you understand this. So I would really look at those. I also will have a bunch of videos available for you. Tyler DeWitt has some really good videos. And then these are what these reactions could look like on these different types. And I think you might enjoy that as well.